You know that feeling when you type a question into a chatbot and it just instantly spits back this incredibly coherent, human-sounding response? It's honestly a little wild, right? You've probably wondered what kind of magic is actually happening behind the scenes to make that work. Well, welcome to This Explainer. Today, we are completely stripping away the mystery. We're popping the hood, cracking open that black box, and looking at the sheer, raw mechanics of how these models actually read and understand the text you give them. Okay, let's dive right in. Our guiding principle today, straight from our source material, is super simple but incredibly important. Assume you are an AI engineer. We are shifting gears. And why does this matter? Because if you only ever look at AI through the lens of an everyday user, you're just going to be staring at a slick interface, marveling at the illusion. But when you actively adopt the mindset of the system builder, everything flips. You stop asking, what does the AI think? And you start asking, how does the system actually compute? We are going to dig into the rigid mathematical realities that make all of this artificial intelligence possible. So, here is our quick roadmap for today's explainer. We'll start with the AI engineer perspective, move into interpreting your prompt, explore context window mechanics, explain the key value query process, and finally, wrap up by looking at concrete KVQ operations. All right, let's kick things off. Part 1, the AI engineer perspective, cracking the system. Let's just sit with this fundamental question for a second. How does an AI actually read and understand? Notice the phrasing we're using there. As humans, we read and understand totally organically, right? We infer meaning, we pick up on subtle tones, we bring literal decades of lived human experience to a single passing sentence. And AI does absolutely none of that. Zero. It doesn't have a brain. It just has a processor. So how on earth does a machine ingest language? Well, it requires a complete, literal translation from our messy human abstraction into strict mechanical action. Moving right along to part 2, interpreting your prompt, the journey begins. Here's the thing. Understanding a prompt requires the AI to completely break down your words into a structure it can actively compute. Your prompt is understood not as human language, but it's structurally mapped out into mathematical data. It takes your words, your sentences, even your punctuation, and translates the whole shebang into a vast array of numbers and vectors. So to an AI engineer, a prompt like, say, write a poem about the ocean isn't this fun, creative request. Not at all. It's a structural input. It gets mapped into a multidimensional space, and that kicks off a highly orchestrated series of calculations. It is structural, it is mapped, and it is purely 100% data-driven. Which brings us perfectly to part 3. Context window mechanics, the thinking space. So the context window is essentially the AI's short-term memory space. Think of it as the defined boundary and active workspace where an AI maps out, stores, and evaluates all of your prompt's data. Because, you can't just throw infinite information at a computer and expect it to process it all at the exact same time. It needs a desk to work on. The context window is that desk. Everything that's currently sitting on the desk can be actively evaluated, but anything that gets pushed off the edge, it literally just ceases to exist for the system in that exact moment. It sets very strict, hard limits on what the model can consider at any given time. Just to give you a really concrete idea of these mechanics, many modern models operate with a context window of something like 128,000 tokens. And a token is roughly equivalent to a piece of a word. To put that massive number into perspective, 128,000 tokens is roughly the length of an entire 300-page novel. This number represents the absolute hard limit of information the AI can actively hold and process at one single time. So if your conversation, all your source documents, and all of the AI's previous replies add up to 128,001 tokens, well, that very first token gets pushed right off the desk and is completely forgotten. As an engineer, managing this space is absolutely crucial to ensuring the AI stays on track and retains the right information. All right, let's get into the really good stuff. Part 4, Key Value Query Explained, the engine room. To really grasp what's happening in this engine room, think of the AI as a highly efficient, lightning-fast librarian. The query is what you, the user, are actively searching for. It's the mathematical representation of your prompt. The key, on the other hand, is basically the label on the librarian's filing cabinet. It is the identifying tag for all the stored information the AI has mapped out within its context window. The system's entire job is to take your query and figure out which key it matches best. So, for example, if your prompt asks, "What is the capital of France?" your query is the mathematical concept of France's capital. The key is the numerical tag on a filing cabinet containing geography data, and the system's only goal is to match your query to that specific key. Okay, let's round out the complete trifecta here. First, you have your query, the active request. Second, you have the key, the indexing label. And finally, you have the value, which is the exact document or specific piece of data inside that labeled folder. Back to our capital of France example, once the query successfully matches that geography key, it opens the folder to extract the exact value, which is Paris. That value is then pulled out of the filing cabinet and used to generate the actual literal words you eventually see typing out on your screen.
And that leads us perfectly into our final section, Part 5, Concrete KVQ Operations, the Process in Action.
Let's track the actual chronological journey of your prompt. Step 1, the AI receives the query. At this point, it has already been mathematically mapped from human language into vectors. Step 2, it scans the context window for matching keys. But remember, it can only scan what is currently sitting on its desk, within that 300-page limit we talked about earlier. Step 3, the AI retrieves the associated value. It transforms abstract text into a seamless, highly structured retrieval operation. Now, this whole sequence literally happens in milliseconds, but this strict chronological order is exactly what is happening every single time you press send. So when we casually throw around the word context in everyday conversation, it means something entirely different to an engineer. To an AI engineer, context is strictly defined as a stored matrix of keys and values. That is literally all it is. The prompt you type simply acts as the new query against this pre-existing matrix. And the context window? It just dictates the sheer volume of keys that are available to scan. If the keys aren't in the matrix, the query is going to fail to find a relevant value. It is a completely closed, strictly logical loop. Realizing that AI reads by basically matching mathematical queries to keys gives you the true, authentic perspective of a system builder. By understanding these KVQ, or key value query operations, the magic of AI text generation kind of vanishes, right? But honestly, what replaces it is a clear, logical blueprint that is, to me at least, even more breathtaking than magic. It is a profound testament to just incredible engineering, structured data retrieval, and the sheer power of organizing human knowledge into mathematical relationships. Before we wrap up our analysis of these mechanics, I want to leave you with a bit of a curveball, a provocative thought about the future of AI engineering. We spent a lot of time talking about the hard limits of the context window, but what happens to these key value query operations when context windows become infinite? Like, what happens when the AI doesn't ever have to push anything off the desk, and the volume of keys it can scan is just limitless? How in the world will the system maintain its efficiency? And what kind of crazy understanding will that unlock? It is absolutely something fascinating to ponder long after this explainer ends. Thank you so much for joining me, and as always, keep questioning the mechanics behind the magic.